All right, if you are just joining us, here is your warm-up for the day. If you are on the beta trip, we have already done these problems. We've gone over these problems. This was a review from yesterday, so you need to go ahead and take a look at these problems in your book, page 130, 27 through 34. So that will be part of your makeup work. Okay. I also made the decision that I'm going to go ahead and click the next slide so you can write down the objective. I've just made I'm only going to do one more lesson this week. It should be 12. Thank you. I even renamed it, but I did 11. It should be 12. All right, it should be 12. All right. I made the decision that I'm only going to do one more lesson this week. Okay, so Objective 12, those that are gone on the beta trip, this is the only lesson you need to watch. Tomorrow, we are just going to spend some time reviewing terminal points, reviewing finding trig functions, and then reviewing what we're doing today. Just kind of putting it all together. So I know I've kind of thrown a lot at you this week. We are way ahead of the other trig classes. So I'm just going to hold back and let's take some time and review and make sure you really got it. Because once I get into the other stuff, like I don't need to move on to next lessons if you don't really feel comfortable with what we're doing. So tomorrow, that's what we're going to take a look at, okay? All right, so today we're going to use our fundamental trigonometric identities to find exact values of trig functions, okay? So we're going to still be looking at sine, cosine, tangent, cosecant, secant, and cotangent. I'm going to give you a lot of properties, a lot of rules, saying that this is what this equals. Like yesterday I gave you and told you that sine is equal to your y. I'm going to give you more of those properties today and more of those identities, and we will carry these through. So a lot of today is a lot of rules that I'm just going to have you go ahead and get down, and then we'll start to use them, okay? Kind of pulling it all together. So here's your first thought, okay? Can I ask you for a second to put your pencils down? Okay, I just want you to put your pencils down. I'll give you time to copy this in like 2 seconds, okay? So what I want you to understand is if I have my unit circle, and we know this is positive, positive, we know this one is negative, positive, this one's negative, negative, this one's positive, negative. Everybody good with that? So let's just look at quadrant 1. If you know, based on what we did yesterday, sine is equal to the y. So will it be positive or negative? Cosine's going to be tangent is y over x. So if I'm dividing a positive by a positive, what will tangent be? Positive. And tell me about all of their reciprocals. If all those are positive, then all the other ones. So this is what this means. I'm going to give you time to copy it down in a minute, but that's what this means. In quadrant 1, everything is positive. All the trig functions are positive, okay? Negative, there are no negatives in quadrant 1, okay? If we go to quadrant 2, we know sine is going to be the y, so it is positive, okay? So you tell me, what's the reciprocal of sine? Cosecant. And we said a minute ago, when you take the reciprocal, am I changing signs? Am I flipping it? So if the sine is positive, would the cosecant be positive? Yes, so that's what that means. Does that make sense? And so let's talk about the cosine. Cosine's your x-coordinate. In the second quadrant, it's going to be negative. If I take the reciprocal of it, what's the reciprocal of cosine? Secant, so would it be negative? Okay, and then tangent's going to be sine over cosine, so I'm going to be dividing a positive by a negative. So tell me about the tangent and the cotangent. They're going to be negative. Do you see where I'm getting all of this? I'm not going to go through every quadrant, but I just want you to understand what you're copying down. Okay, so go ahead and take your pencils. I appreciate you putting your pencils down. So just so you know, in your quadrants, and you're going to want to refer back to this, like those that don't take notes generally may want to take notes. Does that make sense? Because, you know, you're going to have to get your signs appropriate, and you may have to go back to this chart and say, okay, I'm in quadrant 2, and this is cosecant, so I know it's going to be a positive if I'm finding the cosecant. So I'm going to go ahead and hit pause on the video. Y'all take as much time as you need to copy this down. I just don't want my video to be forever long. All right, here we go. So let's move on. So this is one way we use, you know, we have all kinds of tricks to learn things. Yeah, I draw it because I'm going to, like when you're trying to figure out like what's what. So here we say all students take calculus. Does that make sense? There's another one, but I can't think of it. And it goes the other way. Anyway, I might have to see if I remember. That's the one I use. All students take calculus. So here you need to know, like, in the first quadrant, everything is greater than 0. Everything's positive. When I say greater than 0, I mean positive. Does that make sense? Students, that means the sign is greater than 0. And if the sign is greater than 0, what else does that mean? What's the reciprocal sign? Cosecant is going to be greater than 0. So the sine and the cosine, or the sine and the cosecant. Okay? Huh? Yes, because everything's going to be positive. Like sine, and when I say all, guys, I'm talking sine, cosine, tangent, cosecant, secant, and cotangent. Like everything, in quadrant 1, everything's greater than 0. And when I say greater than 0, I'm saying positive. Okay? Because that's what you're going to want to know. Like, is this positive? Is this negative? Okay? Tangent in the third quadrant, you know that the sine and the cosines, because they're negative, negative, right? Sine and cosine, and their reciprocals will be negative. But when you divide a negative by a negative, the tangent is going to be positive. What else will be positive besides the tangent? The cotangent. Okay? And so in the fourth quadrant, we know the cosine is going to be positive. Everything else is going to be negative, except for what if the cosine is going to be positive, then that also means the secant, the reciprocal of that. Because when you take the reciprocals, they don't change signs. So this is a good way for you, like that. This is just an easy way for you to remember that giant chart I gave you. Instead of memorizing what the chart looks like, most students on quizzes and tests, they draw this and they say all students take calculus. And so when you do this, what is this saying to us? These are the ones that are positive. Does that make sense? But you got to include their reciprocals. So in this case, when it's sine in quadrant 2, you got to say cosecant is also positive. Okay? Tangent and cotangent in quadrant 3, and then cosine and secant in quadrant 4. So just an easy way for you to remember it. Got it? All right, so a couple more properties here. So the sine of negative t, the sine of negative t is going to equal the negative sine of t. Just write it down. When we get there, we'll explain it. Okay? The cosine of negative t is going to equal the positive cosine of t. And the tangent of negative t is going to equal the negative tangent. Cosecant of negative t is going to equal the negative cosecant of t. The secant of negative t is going to equal the positive secant of t. So really, they all have the same, they all keep the same sign. Like if it's like sine of negative t, it'll still be negative sine of t. It's the cosine and the secant that will flip signs. And we'll, like I said, if you'll just get them down today, as we get there, we'll discuss more of it. Today is a lot of rules. All right, just a slight note. I feel like I have a typo on this. I feel like this last one should say cotangent of t. All right, couple more rules. So reciprocal identities, and a lot of this you're going to find that you've already seen. Okay, So yesterday, and here's where I'm saying, like, you're gonna see all kinds of stuff, and I want to see identities. Sorry about that. I want to see if you can start to put it together. Like, this should make sense to us that yesterday I told you that the sine was equal to what? Sine's equal to the y, and we learned that cosecant was equal to, no, it was the reciprocal of it, 1 over y. Not the cosine, the cosecant. I can't spell today. Make that a little bit. So does this not make sense that if we know that y sine is the y, that this would be the same thing as 1 over the sine? Would that not make sense to us? Because it's the same thing. If sine is equal to the y, and so we know sine is your y coordinate, so we know cosecant is the reciprocal of that, 1 over y, then it's going to be the same thing as 1 over sine. So, like I said, a lot of this is going to seem redundant. Like, we've already done this, Miss Corns, but I want you to realize that it's the same thing, okay? So we're going to refer to it. So I'm just going to pop all of these up here and make sure that you're good with them. Okay. So does it not make sense to us based on what we learned yesterday that secant, we know that cosine's equal to the x, and we learned yesterday that cosecant was 1 over x. So wouldn't that be the same thing as 1 over cosine? Yes. Okay. Same thing here. Cotangent, another way to think of it is 1 divided by the tangent. Okay. Another thing you can do, we learned yesterday that tangent was y divided by x, which is going to be the same divided by the cosine. Okay? Cotangent is the same thing as cosine divided by sine. When we start simplifying trig identities, like remember when we went over factoring and I said this is how you're going to see it. You're going to have to factor like a sine out or a cosine out. You're going to have to start using that. When we start, I'm going to give you like a massive trig identity. It's going to be like a puzzle. Like some of you are going to like love this. These are my favorite. But you're going to have to like take it, like when you see cotangent, you're going to have to know, oh, cotangent is the same thing as cosine over sine. And you're going to have to take it and make it that. Then you'll realize, oh, those cosines cancel. Oh, those sines, I can do this. And so you're going to be using this a lot. Okay? Any questions about that? Everybody understand it's the same thing you learned yesterday, just looking at it in a different way. Okay. All right, almost finished. So I think this is the last identity. Don't quote me on that. But we're going to talk about Pythagorean identities. So before I pop this up here, I want to see, based on what we've talked about today, to see if you can come up with the Pythagorean identity. So Pythagorean deals with what specifically? How about right triangles? Because we know, what's the Pythagorean theorem say? All right, so that's what you got in geometry, right? A squared plus B squared, if you take the two legs and add them together, you get C squared, correct? So let's take it and apply it to the unit circle. So the other day we learned that C on the unit circle was equal to what? Which was the hypotenuse, which is 1, right, on the unit circle. And we learned that this would be X, did we not? And we learned that this would be the Y. Like if we plotted the point, we go over X and up Y. So the other day we talked about X squared plus Y squared is equal to 1 squared. Any questions about that? This is all we're doing. I want to put it in terms of trig functions, like sines and cosines. Cosine squared x plus sine squared x is equal to 1 squared or just 1. that make sense? It is 1 squared, but 1 squared is 1. So voila, you just came up with your Pythagorean identity based on trig functions, okay? But that's where it came from, because we know that cosine is your x's, sine are your y's, and so that you will be able to use that. So let me just pop these up here. Here's the first one. And it doesn't matter whether you say cosine squared t or sine, it's the same thing, right? X squared plus y squared plus x squared, it's the same thing. Okay, sine squared x plus cosine squared x is equal to 1. Here's another one. Tangent squared plus 1 is equal to the secant squared of x. There's one more. And again, you need to memorize these because when we get into simplifying trig functions, I can't wait for that. It's like my favorite part. You're going to have to, like, if you see tangent squared x plus 1, you're going to be able to take tangent squared x plus 1 and make secant squared x. Does that make sense? And then you'll take secant squared x and know that secant squared x is the same thing as 1 over cosine squared x. Does that make sense? And you just have to, like, keep changing it into what you know is equal to it. Have I blown your mind with that? A little bit? Slightly? Okay. So I have 2 examples for you today. So let's start slowly. Okay, I just want to start slowly today. 2 examples, and so we're almost done. Do you need a stretch break or anything? Yes? Okay. Take a stretch. So let's go ahead and continue on with this. So on this problem, I'm telling you, I'm giving you a hint, that the cosine is 3/5, and I know that my point is in quadrant 4. So I'm going to go ahead and do this. All students take calculus. And I want to find all the trigonometric functions of t. And someone said, what does that mean? When I say give me the trig functions are what? Cosine, sine, cotangent, tangent, all that good stuff. So over here, I'm going to kind of go ahead and make my list. Sine, cosine, tangent, cosecant, secant, cotangent. Okay? Now, let's fill in what we know. Before we get started with this problem, this is going to be my answers over here. This is what I'm looking for. What do I already know? I know the cosine is positive 3/5. So give me something else that I know. The secant is going to be 5/3. I want you to look at, I drew your little circle up there. All students take calculus. Okay? We hope, right? All students take calculus. Some of you are thinking, no way, no how. But let's just go with it for now. Let's just, all students are going to take calculus. All students take calculus. So, we're in quadrant 4. Tell me about the signs. What do I know is going to be positive in quadrant 4? The secant and the cosine. Oops, let me go back. Sorry. We know that cosine and its reciprocal, so we know the cosine and the secant are going to be positive. So what can I go ahead and do with all 4 of these? I can make them negatives. That way, that's how I use that. Does that make sense? I already know that they're going to end up being negatives. So the question is how can I figure out, like, I know the cosine, but I don't know the sine. So let's use our Pythagorean identity that we just used. Okay? Cosine squared x plus sine squared x is equal to what? 1, which is the same thing as a squared plus b squared equals c squared. Does that make sense? It's your Pythagorean theorem. That's what we're going to use. So we know that the cosine is 3/5. So I'm going to plug in 3/5 squared. We know that this is going to be sine squared x. What could I put in there instead of sine squared x? You could put y squared if you want to. You can leave it sine squared x. It's fine. Either way. It's the same thing. Everybody understand that? Same thing. So my question is can you solve for y? Yes. So if I did solve for this, this is, if I square both, that's going to be 9 over 25 plus y squared equals 1. Now what? Okay, take the 9 over 25 over and subtract 9 over 25. So y squared is equal to 16 over 25. Everybody with me so far? How do I get rid of the square? Take the square root. So what's the square root of 16 over 25? What's the square root of 16 over 25? Plus or minus, right? So here's the thing. This is where people start making careless errors because they just say 4 over 5. And they would come over here and they would put 4 over 5. But I need to pay attention because I am in quadrant 4, which means that the only thing that's going to be positive in quadrant 4 are your cosines and your secants. So this is going to be negative 4/5. So my thought is this. Can you, if I give you a couple seconds, can you go ahead and fill out the rest of it now that you know? Now this goes back into it, because yesterday I gave you the x and the y, right? So don't you have the x and the y now? And then you found all the others? Maybe. So let me give you like, it's 16. I couldn't get it to, it won't draw my 6 for me. Because 1 is the same thing. You can put it in your calculator, but 1 common denominators would be 25 over 25 minus 9 over 25 is 16 over 25. Okay? All right, so take a couple minutes, fill in the rest of the chart now that you know what you know. So let's go ahead and start. Let's take a look at this. So we know tangent is what? We know tangent is the y over the x. We also learned today that the tangent is the same thing as sine over the cosine, right? So negative, maybe not, negative 4/5 over 3/5. What do we know is going to happen to the 5's? So what's it equal to? Negative 4 over 3. Okay? All right, and you can, like I said, if you don't like it that way, you can do the trick and simplify. Okay? All right, cosecant. We know cosecant is the reciprocal of negative 4/5. So what would it be? Negative 5 over 4. Just flip it. Okay, you don't have to rationalize or anything because there's no square roots. Okay, we've already got the secant. We know cotangent is the same thing as the tangent, the reciprocal of the tangent. So it's going to be negative 3 over 4. Any questions on that? So go ahead. Right. Unless it's got a radical in the denominator. Then you got to rationalize it. Okay? So here's one thing I could stress to you. When you're making your list, keep it in this order. I'm going to say it again and again and again. Keep it in this order. I find these 3 first, and then I take these and just flip them. Okay? And then if that needs to be simplified or rationalized, then I do that. Okay? All right, so I'm going to give you one more for today. I'm going to have you do it on your own. Okay? I'll get you started. I'm telling you that the tangent is equal to negative 4. And the cosecant is greater than 0. So, first thing that I would do is I would draw it. Okay, all students take calculus. So, first of all, I know it can't be in quadrant 3. Do you know why it can't be in quadrant 3? Because tangent's going to be what? And what do I know the tangent is? Negative. I know it can't be in quadrant 1 because what's positive? Everything, and we know the tangent is negative. So it's either in quadrant or quadrant 4. So they give me another piece. And they say the cosecant is greater than 0, meaning the cosecant's positive. So if the cosecant's positive, what else is positive? What's the reciprocal? The sine. The sine, these are cosecant, the sine is the reciprocal of that. So I know that the sine is positive. So what quadrant are we in? Which one does the sine positive? 2. So I know I'm in quadrant 2. This is where this is where I am. I'm in quadrant 2. Okay, so I might even put that. Okay, I'm going to make my list. Sine, cosine, tangent, cosecant, secant, cotangent. I'm going to fill in what I know, and I'm going to look at the theorems that I've given you today and see if you can figure it out. Okay? So I'm going to hit pause and see what you can do. Okay, so based on this, let's just go ahead from the get-go and do our signs. I would do that first on every single one of them. That way you know what you're using. So we already figured out that we're going to be in quadrant 2. Is everybody okay how I figured that out? Okay. So that means which ones, like, what would the sign be? Positive. Wish my board would work. Positive. Cosine's going to be, tangent's going to be, cosecant's going to be, secant's going to be, cotangent's going to be. All right. Thumbs up if you understand that. Like, you got that far, right? Okay. Now, let's go ahead and fill in what we know. We know the tangent is -4. That's cotangent, right? -4. Whoops. -4. So what is the cotangent? How do you get -1/4? So I'm going to have to just scribble this out because I can't get my eraser to work. Sorry about that. So this is going to be -4/1. We know that these are reciprocals. So this is going to be -1/4. How do you feel about that? How many were able to get that far? Like you knew that these two were reciprocals of each other so you could flip them. Now the question is, I don't know what the rest of this stuff is. So that's where you have to refer back to the equations and the identities. A minute ago, how did I know to use sine squared x plus cosine squared x equals 1 a minute ago? Because we had the cosine. So here's what I'm going to tell you guys. If they've given you cosine, then you're going to use the equation that has cosine. They've given us tangent, so we're going to go find the equation that has tangent. And so we know, because of what I just gave you, tangent squared x plus, and I'm going to use x instead of t. You can use t, you can use whatever you want. I like tangent squared x. Okay, tangent squared x plus 1 is equal to the secant squared x. So my question is, because I know the tangent squared x, can I plug in -4 here? What will I be able to solve for? I will be able to find secant. Okay, so when I square that, that gives me 16 plus 1. So this is 17 equals the secant squared x. This is still squared. Don't because, secant, treat it just like you would a variable. So how do I get rid of the square? I'm going to take the square root on both sides. So these, what happens, Gonzalo? They cancel. They just cancel. They don't, you mean really? They don't cancel. Okay. They just cancel. All right. So this is going to be equal to plus or minus square root of 17. Now, if square root of 17 can simplify, you guys simplify it. You follow me? But 17 can't simplify. So we're just going to leave it square root of 17. So my question is that negative square root of 17 or is it going to be positive square root of 17? So we want negative square root of 17 right here. Okay, so now what can we find? We can find the cosine because we know that the secant and the cosine are reciprocals of each other. So this would be negative square root of 17 over 1. So if I flip it, it'd be 1 over negative square root of 17. What do you got to do with it? Rationalize it. So what's your cosine going to end up being? Negative square root of 17 over 17. All right, we're almost there. Now, I still don't know how to get the sine and the cosine. So here's what or the sine and the cosecant. So, but I know all these others. Hold that thought. Okay, so there's multiple ways. Like, you know what I'm saying? Like, here's where you get into, there's probably is a wrong way. I'm sure there's a wrong way, but there are multiple right ways to do this. I would refer back to good old faithful, we feel very comfortable with x squared plus y squared equals 1 squared, right? Like sine squared x plus cosine squared x equals 1. So that's what I'm going to refer back to, if I can get there. I just want to erase. Please erase. Okay. Whew. So I'm going to refer back to that one, and then we'll go your method and see if that works. Okay. So I'm going to go back to, once I know cosine, I can go back to sine squared x plus cosine squared x is equal to 1. I know cosine squared x is negative square root of 17 over 17. Sine squared x equals 1. Okay, so let's square this. So sine squared x is equal to positive, not equal, plus, this is going to be, when I square root of 17, what am I going to get on top? Square root of 17 times square root of 17. 17 over, no, you got square 17. 289 equals 1. I really think that simplifies to 1 over 17. It doesn't matter if you want to simplify it to 1 over 17. You can put this in your calculator, okay? And then I'm going to subtract it. So somebody in their calculator, take a minute and do that for me. 16 over 7. 16 over 17. Very good. So far, so good. And then we're going to take the square root of this. So this is going to end up being sine of x is equal to plus or minus, what's the square root of 16? 4 over the square root of 17, but what do you got to do with it? So times by the square root of 17. So this is going to end up being, our sine is going to end up being positive 4 times the square root of 17, all divided by 7. Let me just finish this up. All right, last one. So how do we find the cosecant? Just take it and flip it. I do think you could go back to, keeps flipping. You could go back to this and flip that before. I don't know if that confuses you. You could flip that. So what do you get when you flip 4 square root of 7? Or you could do this, flip this one. I feel like it's just going to be square root of 17 over 4. Because I flipped it from there. Does that make sense? If the sine is equal to 4 over square root of 17, before we rationalize it, when I flip it, it'll just be square root of 17 over 4. Exactly. And you can take it from different directions. Let me say this really, really quickly, and then I'm going to end. I know, go ahead. No homework. I'm going to, I know I have like blown your minds with some of this stuff today. We're going to take all day tomorrow. I'm not going to teach you anything new. We're going to go through this. But can I say this really quickly? Kerrigan asked me, she said, instead of doing this equation, she said, if you divide this by this to get this, could you divide 4 by this to get that? I'm not sure what you're asking. Oh, right. You were trying to take, okay, so -4 over 1, and you were trying to make it this over that, but there's lots of things that could reduce to -4. So no, I don't think you could just take -4 over 1 and say this is your x and this is your y. So you're going to have to end up using these equations. I'd say these equations are a safe bet to like refer back to. And then once you know part of it, you take it and just flip it to go to the other part.